last Friday, came down with a cold. Yuck, yuck. A couple of things here. First, I keep forgetting to talk about this little test I did. I did the video on Anchor Lube and water-soluble oil, and I was using the Anchor Lube on one of my favorite dovetail cutters, and it hit me that I'm using water-based products on my steel tools. So I did a test. It just took a piece of 1018 and globbed soluble oil with water on it on one end, Anchor Lube on the other. This is well over a month old now and not one bit of rust on it, so just a heads up on that test. Thinking about going to the Barzee Summer Bash. Been trying to figure out where it is. It's somewheres up in Los Angeles. This morning, I may be too late, they're probably booked up, but I found an email address, sent an email off asking about it. So since I got two pieces here for you, since I missed last Friday, I already had taped an update on the engine that I'm making. So you'll see that, and then you'll see another update on the engine. So here you go. Update. So the other dual cylinder engine is on the shelf for a little while. So I'm updating you on building this one, which is the one from the February 1950 Popular Science magazine. I've already shown or said some of the dimensions are wrong, but figured let me make the cam first. If I can't make the cam, then I can't make the engine. So it's coming out. I need a pencil here. So I went out and bought the giant piece of 2-inch aluminum that was needed. Put it in bandsaw, cut it off a little bit bigger than size. This went in the chuck, faced it, cleaned up the outside, chamfer it, turn it around in the 3-jaw, and turn this 1.5-inch dimension. Then they show you've got to move up some 15-30 seconds. So rotary table goes on, center hole of the table centered. This part's put on the table, manually centered up with a little pointer on the mini pallet, and then they say you got to shift it the 15-30 seconds. Look at the DRO, shift it 15-30 seconds. 1/2-inch end mill, rotate, and easily cut that, so no problem. Another problem is they show here you need from this invisible hole moved up here, you want to go 30 degrees. Here they show from the center hole you want to go 30 degrees. I did it from this hole. I just rotated this thing 30 degrees and made a little divot. So there's the cam. I don't think it's that critical. This distance here is telling me how much you got to open and close on the cylinder, the little opening to let the heat in and air out or whatever. So it seems to be adding up right. So that's done. I can easily find the center again on the mill and drill whatever size shaft I'm going to use. So figured that's done. This one I sure didn't put on my engineering hat and really study first, but because I'm looking, okay. So I had the 2-inch from doing the cam, so I'm going to cut off 3 inches of that, and I started making it. This thing is giant. And looking at the YouTube video of this guy running, it did not look this big at all. So needless to say, they don't give you the dimension from here to here, I'm guessing. A whole bunch of this I'm guessing on. And you want to get bored, man, just sit there and like I said, when I'm done, if this engine works, I will document every inch of this thing with tons of comments and heads up. One of the comments was, I thought I was doing a pretty good job, so there's no DRO on the saddle, but just looking at the dial, and it looks like one of them I went deeper on. But yeah, it's critical to keep them all the same depth if you want this to look good.
This was 2-inch was chucked up, faced, cleaned up, and then all the cutoff tool, grooving tools, made all the grooves, made the final mark, turned it around in the 3-jaw, took this down to the dimension they're talking about. I actually didn't go 1 inch. I came close. I think I'm at 85 thousandths in here. 850 thousandths or so. It might even be 900 thousandths. So I turned this down, cleaned this up, and then drilled in as far as I could go here with the drill bits, because this is pushing it too. And the same way I started boring this out. This was the maximum. I mean, it's as far as I can go. The biggest boring tool I've got. So bored it all out. Then put it this way in the vise in the mill. Fly cut it down just till it was when they gave a dimension here. I came down a little bit further than that. 1/4 inch, 2 flute, and I'm learning 2 flute end mills is the only thing should ever touch aluminum, because 3-4 flute just clogs up. So 2 flute, 1/4 inch end mill, drop it down, drop it down, drop it down, then start cleaning it up, go over 3 thousandths, and then start walking around to get it nice and clean. So this guy's done. Because this was a casting, you had legs on it. I'm not sure how I'm going to mount this thing yet. But, alright. So that's done. And I went to the Industrial Metal Supply to get this, a 3-inch, they want 3 3/16, 3-inch piece of brass, $85. I just ordered it off eBay. The 1-inch thick for $21. So that's on the way to make the flywheel. So I'm getting there. Then making, yeah, I didn't want to do the plug, so it's just solid. I could have probably done that, but nah. So now piston, and there it is. It was kind of fun and easy to make. I'm not too thrilled. That was supposed to be 100 thousandths thick, and I went too far here. So this back wall isn't very thick on it, but yeah, just came right up on the dimension. And it fits perfectly. There's like, it doesn't drop out until, yeah, it sticks because there's dirt in there. Why is there, I can feel a little nick someplace. So it does hold pressure. There, it drops out when I let go. And I even tried a flat piece of metal on here, and yeah, this was 3000 grit on the granite block, just getting it smooth. Looks like I don't need to do it anymore. So I've got the piston, doing that. Boy, that's a tight fit, let me tell you. That's a neat fit. Tried a little bit of 3000 in there while it was in the lathe for what it was worth to smooth it out. I'm still concerned about expansion. I don't know how much this is going to expand when it gets hot. Will it seize in here? They don't tell me any clearances. They just say, make this 1 inch or make this 1 inch. Well, that ain't gonna work. So, huge thing, let me tell you. Impressive though. It's fun to have. So I'm working on this guy, and now they're saying this part. I don't know how to make this yet. I tried doing a little bit of this. It's not, because my wall's so thin, I need a nut to stabilize it. But I'm trying to figure out how to hold this. So right now, that'll be the next part to do, then the rods and all of this, and then the flywheel material should be here. So that's just kind of an update for now. And I was thinking 1018, it's going to beat this aluminum piece to death. I might have to remake this thing. I don't know. Because that is just nothing in it. I think that's about 50 thousandths here. So it should be thicker. So let's see where I go from here. A few more pieces to make, and then try to figure out how to mount this in a base. So that's the update, guys. Oh, I just wanted to say one other thing. Remember when I was talking about anchor lube versus just soluble oil? I was thinking, hey, wait a minute, I'm using a water-based product, Anchor Lube, on my steel tools. It's going to rust. Same way with water-soluble oil. It's got water in it, and it's going to rust. So I did a test. This now is well over a month old. I put a Anchor Lube all over this side and blobbed it, so it was, just let it be. And then the water-soluble oil on this side. And as you can see here, not one bit of rust on it. This test has been sitting here for a long time. This is 1018. I don't see any rust anywhere, so I guess I can finally wipe this off. Yeah, it's still shiny. Look at that. Wow, nice. So I can finally wipe this guy off and throw it in the drawer. Test is over. I keep forgetting to report that. Okay. Okay, share what I have so far. I think everybody's seen this piece, I'm not sure, but yeah, I built this before I did the print. So I'm starting to backtrack, and anything that I'm building, I'll do the print first, then build a part. That way I know I'm not missing anything on it. This is the mount. It's going to go on another page. I just drew it in there. But this guy came out pretty good so far. I'm having to come up with dimensions because there's nothing in that print from the scientific or Popular Science or whatever about depths, fins, this, that. So, and even on a lot of the dimensions, I'm kind of off, not from what they're saying. This guy was lapped on the granite surface, 3000 grit, and it's kind of getting messed up from handling, so I'll have to redo it again. I accidentally did that hole, shouldn't have. I was figuring I was going to drill it out, so I did a spotting drill. And went in with a Dremel tool with a little buffing wheel, and it's super slick in there, and made the piston, and it just fits. I've got good compression. These prints, when I'm done, if this thing works, will go up on the website, so if anybody wants to try it. The only thing I didn't realize was if you get, and I put the note in there, if you aren't consistent with the depths, when you shear this off, you'll see like this one is deeper than the rest of them. So I must have been one more revolution on the dial. Accidentally do that, but we got instructions how to do it step by step, kind of. So that's the first piece. And the mount, I haven't dimensioned yet, but it came out in big chunk of aluminum. Boring tool, it was a lot of work, let me tell you. So this guy is going to just kind of go right there, a little bit flush. Don't know how I'm going to secure it yet. I was thinking just drill a hole, put a set screw in there, but I didn't want to mark up this surface. So I've got the hole. I got to get some stainless screws, but I'm just going to use these for now. Get in there. Yeah. Alright, well, it goes in. A little bit loose on purpose so I can move things around. This guy too has got some movement to it for this. And what was the next print here? And I suggest building them in order. That's why I have part 1, 2, 3. Building them in this order, because if you can't do this, don't even proceed. This I haven't done at all. That's the cam. I don't think anybody's. Yeah, you guys have probably saw it. One piece. So finally drilled this out for the piston, which is here. I haven't drilled this yet because he's going to mount right there. But this guy goes together. This is the second one. First one was just too big looking. So there's the guy, and he's going to go, what, all this goes this way. Oh, he's going to be out. Oh. And what? This is the piston end. The screw goes on the other side for the piston. Piston goes in there. And I might rebuild this, lap this thing some more. I'll have to see. But yeah, you hold on that thing, and it doesn't want. It's got vacuum in there. So, and then I had made the little cam guy, brass rod, pressed it in there. Still a little loose. I'm probably going to have to Loctite it in there, but he's going to go there, and he's been lapped. and it does hold it. Harbor Freight spring assortment. Wish I had a little bit smaller diameter, but this guy will work. So I've got to build the piece that goes here to the cam that rides on it. What was I gonna do? Oh yeah, I had out of a hard disk a bearing. So this will, I got to get rid of this whole lip that's on here. Just turn that off, and he'll go into a little pocket in another piece here and do that. So that's this guy so far. What was the next sheet? I think the next sheet was just all the miscellaneous stuff. Yeah. And I haven't dimensioned that guy, like I said. So all the rods, the lengths, these dimension. I haven't said the thread because I haven't finished this paddle guy. That has to be built next. And the mounts for the flywheel, and then the base plate, and I can try firing this thing out. Oh, I got to find something for the fire, alcohol fire. So, and as I realize things, I'm adding notes that you can see in here, penciling them in. Flywheel, I just turned $21 chunk of brass, 3 inches in diameter, 1 inch long, and I'll tell you, I calipered it when I got it off of eBay, and it was 16 thousandths over 1 inch. But talk about a hard job, because trying to do this, go in to cut it, you just get chatter. And you can make a tool that'll clean this up, but now how do you make it nice and clean to this side? So this one day to do one side, next day to do the other side, and this morning I just finally turned the outside and did the holes. I forgot, and I added them to the print and figuring out the dimensions for where to center it, end mill. But yeah, it's regular. I wanted to do drill bits first, undersized, and then drop the 3/8 end mill in there. And yeah, drill bits do want to grab, let me tell you. So to do this on a rotary table is fun. There's still grooves and ugly things in here, and I tried buffing, but I'm giving up making it any better for now because I want to see this thing work. And yeah, it's pressed on there. It's a press fit job. And boom! And there's a lot of mass to this thing, let me tell you. Can I get it off? Ah! There we go. Just got it out. But yeah, you just tap it on there, and it's done. That is cool though. I like the brass. Stainless steel axle, turned down. Just have to cut it off to length. One of these prints says, oh, this has got the axle length 2 inches. So that's where I am so far. Very close, and yet still quite a bit more work to do. It's been, what, 2 weeks on this guy. And if you want to make chips, do this thing, because it makes chips, let me tell you. Alright, that's the update, guys. Yes, brass chips everywhere. This was just, I've already vacuumed a lot of this stuff up. Here's just from doing the flywheel this morning. So there's junk there, it's on the floor, all over the place. But here's from doing the other stuff. I mean, that tray is full, and it's been vacuumed like 6-7 times. So, like I said, if you want to make chips, boy, this'll do it, alright.